Good morning, everyone. It's April 3rd, I believe. Am I correct on that? Yes. 2017. What are these funny pictures of what on the screen? Kind of nasty looking, actually. Pretty sharp. But what I'm looking for, sharp in the sense of penetrating, that one looks less threatening. We call this a jack. Uh, it's used to play a game, right? I never played it much, but you throw the dice up in the air and pick as many jacks up as you can. But these things are also used as weapons and to pop tires. See, you can see them here. So I know when I pull up either jack or caltrop, I'm going to see some nasty devices. That's a caltrop there. Caltrop only has four spokes coming out from the center, whereas more like the methane atom, or molecule I should say, whereas the jack, of course, has six such things. So I'm just Google imaging on caltrop and jack at the same time so I can contrast them. Now, why would I do this? Because I am starting to get into the concept of dimension in Synergetics in particular. Now here's where I should show a first book. It's kind of reading rainbow today. I have 3 or 4 books to show. Now this is not the most recent edition of The Fourth Dimension and Non-Euclidean Geometry in Modern Art by Linda Dalrymple Henderson. She's a professor of art history in Texas, I believe in Austin. She's a professor of art history at the University of Texas, yes. Assistant professor, maybe full professor by now. This was Princeton University Press. What this book is about is the history of the concepts of the fourth dimension. Now, we're all schooled almost religiously, dogmatically, I'd say, in terms of height, width, and depth, being the 3 dimensions of space. We've got this Kleenex box here. I don't know if you want to call that height or whatever, but there's 3 of these arrows coming out, and as part of a jack, you could say it's the 1 quadrant of the jack, right? The jack divides space up into octants. So like the X, Y, Z coordinate system, you know all this. The 3 vectors of X, Y, and Z span out from this central origin on the Kleenex box. But then they have to also go the negative direction if we want this origin to be like symmetrically surrounded by spokes. If that's the origin and there's just 3 going off, that's not really symmetric in space. We got to have negative Z, negative whatever, right? We need 3 more to get the full jack. Now I'm going to contrast that with the caltrop in terms of creating a coordinate system to help you realize what Fuller was saying when he said 4D as distinct from what some other people say when they say 4D. So what this book is about is how at the turn of the last century, from 1800 to 1900, right, there was a huge explosion of interest in what we could call multidimensional geometries. I mean, after everyone had learned that there were 3 geometries in space, then what's going to be the fourth dimension? That's going to be mysterious. That's going to be interesting. That's going to be something to talk about, cocktail parties. So there was this sort of an emerging gossip, you might say, of what is 4D. And this book chronicles that a lot of people got in on that and had a lot of stuff to say about that. There was kind of a shakeout, though, I would say, over time, as we get towards the back of the book. I think it sort of settled down into 2 main streams. And they're not the same. That's part of what I'm going to lead up to. And then I'm going to bring in Fuller's 4D as a third option. So what were the 2 main streams? Basically, we all hear that time is the fourth dimension. So you've got X, Y, and Z, and then time is passing, right? Tick, 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 tick. So there's another dimension that it's not spatial, it's temporal. And then we get the Einstein's theories of how space-time intervals are absolute in a certain way, depending on which inertial coordinate system you're in. You might see things in a different order, all of that, relativity. That's a different mathematics from what Coxeter is up to, and many others, Conway in his multidimensional sphere packing book and so forth. Multidimensional sphere packing and regular polytopes are extended Euclidean. You're using the same distance formula you use with ordinary distance, x squared plus y squared plus z squared. Square root of that's the distance, except you just keep adding axes. Now, how do you do that? How do you keep adding perpendiculars when there's only three? Well, hand wave. You don't have to visualize it. Anyway, it gets to the point where some people can visualize it and some can't, and it's kind of almost like religious at a certain point. However, on page 119, I want to jump into this Coxeter book, Regular Polytopes, famous book by his, and I know this page number. Little, if anything, is gained by representing the fourth Euclidean dimension as time. In fact, this idea, so attractively developed by H.G. Wells in The Time Machine, has led such authors as J.W. Dune and Experiment with Time into a serious misconception of the theory of relativity. Minkowski's geometry of space-time is not Euclidean and consequently has no connection with the present investigation. So he's saying, don't confuse the Einstein 4D with my 4D in here. This is Euclidean 4D, and that's non-Euclidean 4D, the Einstein stuff. Now, Fuller, he waits until he's quite an old man before he comes out with his magnum opus, Synergetics, in 2 volumes. There are numbered passages, kind of like Wittgenstein did in Tractatus, Philosophical Investigations. I'm arguing it's a philosophy. It's useful to number passages. It's not tendentious. It's not pretentious. And then they dovetail. You can sort of shuffle together his 2 volumes, and that's what was done by Bob Gray in putting Synergetics 1 and 2 on the web. So Fuller is not buying into any of that height, width, depth stuff. He's not really following Edwin Abbott. I know a Carl Abbott. Edwin Abbott wrote this very popular book called Flatlands. And he did an interesting thing. He kind of mixed levels of consciousness with the idea of dimensions, because these flat beings looking for something flat, or like this pencil being looking at another pencil being, it just sees a point. Or a record album just talking to another record album, totally flat. They don't really see what we see because we're three-dimensional, so we can look down and see that, it's not just a line, the way that books see each other when they're flat. But not books. Flatter than books, right? Infinitely flat. What would it be like to be an infinitely flat being? And I would argue, kind of in a Kantian sense, there's no way to imagine that. And actually, that book was political satire, and it doesn't really take you into a good meditation on what it would actually be like to be a flat being. I don't think we can imagine that. And the reason I say that is because why do we say space is 3D after all? I mean, when you turn that 90-degree angle, what is the magic that makes that another dimension? It's like you go around the block and it's like, I'm in another dimension. Well, the word dimension is slippery, I think, is where Fuller came to. And it's bound up in different language games, which I would also say are namespaces. And there's nothing wrong with having, say, 3 distinct language games or namespaces in which 4D gets used. I think one of the most immature philosophy arguments I've heard is when you say, well, what I mean by gravity isn't quite what you mean by gravity, and they say, well, then you should say schmavity. Like, if you don't mean what I mean by gravity, say schmavity. But that's the thing. These words have connotations, they have history, they have inertia, and to relegate everybody who doesn't use it the orthodox way off to the side with these other stupid words That's imperialistic, right? I mean, if I want to use the word gravity in something, a poem or something, and mean something different, it's up to me to make that happen, to make it work. And in the humanities, we do that. I mean, in a philosophy department, it's not uncommon to take someone like a Heidegger. They'll repurpose words all the time. They'll take perfectly ordinary words that we all think we know what we mean and morph them into something new. And Fuller does this. He does that more than he invents words. I think Fuller gets a reputation in Synergetics for inventing a lot of new words. It's not the case. He invents a few. More, he takes existing words and uses them in a unique way, in his own way. So this is Caltrop coordinates. Instead of X, Y, and Z, you have 4 spokes off from the center. I should bring up the quad pod at this point by Hop. Great little piece of art, which I think demonstrates even more succinctly what we're talking about. It's in my blog here, Control Room Quad Pods. This is a sort of a quad ray. Maybe it's not in the plural. Let's search on the singular. And let's do it correctly. Let's stop trying to be too clever here. Quad pod. So this is like a spaceship that has only 4 rockets to shoot with, but linear combinations of those 4 jets would be enough to go in any direction. And what this Caltrop allows, the 4-spoke thing, is the dividing of space into just 4 quadrants instead of the 8 octants of X, Y, Z. And yeah, 3 coordinates are enough. One is going to be 0 along any of these. In any of these quadrants, you're going to be able to span that quadrant with a linear combination of the 3 edges bordering that quadrant. So it's like 3 dimensions in every direction. Each quadrant has its own 3 dimensions, but not really. Let's just call this whole thing 4-directional. It's like an arrow heading off into these 4 directions, filling space, and you can map all space using this. Now, in normal linear algebra, would say one of these is not linearly independent because it can be made by a linear combination of these others. But that's if you allow negation. Negation is actually rotation. It's flipping a thing by 180 degrees. We're not allowing that or needing that of our basis vectors. They can just stay pointing the way they are, and without negation, we can get to all the points. In fact, we don't need negative numbers. We also get whole number coordinates for our centers of closest packed spheres in the isotropic vector matrix. So it's an interesting, coordinate system. It's not going to take over. It's just another coordinate system, dime a dozen in a way. But it does, I think, help you understand what Fuller meant by 4D, because the tetrahedron, in a sense, is a simplex. It's the simplest container. We feel like we're inside something in space, and we have things that we are outside of. We have things that are containers. Let's think of them all primitively, most primitively, as tetrahedra. I mean, ultimately, topologically, if we take out curvature and everything and just try to get down to bare bones, tetrahedra are a better representation of the concept of volume than cubes. They're simpler. They have fewer edges, fewer faces. So let's say space is 4D, 4-directional. That's what Fuller is talking about, and he means spatially. And he's not saying that there are any fewer dimensions. He's kind of like Carl Menger in proposing a geometry of lumps. Let's just say everything in volume is a tetrahedron. You can roll it out like a sausage, make a line. You can roll it up as a clay ball. That's a point, small as you like, infinitely small if you need infinity in that direction of small. Don't know why you would. All of that. That way we just have 4D is sort of pre-frequency. It's before we get to time. Kind of if you want to do the Einstein thing of separating conceptuality, like the tetrahedron is not in any particular place or time, with a real tetrahedron that has actual heft somewhere in space, somewhere in time, That's what we call frequency. That's where we live. So time is really almost a fifth dimension in this case. 4D just refers to, res extensa, as the Cartesians would call it. Now that's a different namespace than we're used to. It's not this stuff we learn in high school or elementary school about X, Y, Z in three dimensions, height, width, and depth. I'm not saying that's going away. I'm dogmatic about it too. I teach the same thing. If it's dogmatic, I'm a dog. So, I mock it, and Applewhite thought that was funny. For the purposes of this essay, I point out how people get really religious once you start talking multi-dimensions. Some people can see them, some people can feel them, and multidimensional starts to be a doorway back to religion. And I'm not against religion. I'm just saying, look at the cultural memes involved. Look at the whole anthropology of dimension talk. Don't just accept it blindly. And the Fuller stuff actually helps you not accept it blindly simply by giving another alternative. So there you go. I hope that helps elucidate how to read Synergetics. It needs to be appreciated as a work that takes known concepts and words that you're familiar with but uses them in a different way. And so you may think it's nonsense before you think it's starting to make sense. Because at first, all you have, what you bring to your reading of Synergetics is your past understanding of everything. And it takes a while to readjust and refocus and see things more the way Bucky wants us to see them. And then you can go back and forth. It's not like you're giving up. You don't have to drink the Kool-Aid and then never understand what you used to understand. You can always use as much XYZ, height, width, depth, three dimensions as you want. All right, that's a lecture on dimensions in Synergetics. I hope that was entertaining.